Okay, so this is what we looked at all along. We introduced statistics. I remember giving you the formula for finding the mean. We said you can find the mean using two approaches, using assumed mean and also using the normal formula. The formula is there, you can see it. I also talked about the mode. That's how we find the mode, and I think you recall how to do it. Then we went to the median. The formula for the median is here. We said you get the lower class boundary plus n out of 2, where n is summation f minus cumulative frequency before divided by frequency of that class times c. And we had a couple of examples on that. And I gave you this example where we made a frequency distribution table using tallies and all that. Hope you remember. We also added cumulative frequency. Since the median requires cumulative frequency, we included cumulative frequency, and we said cumulative frequency gives us positions. So we looked at that and did that example successfully. We went on and did another example. We're doing this and we're interrupted by network. I remember I continued with it on the board. I think you can even finish it up. We're asking for the median mark. Median mark has been repeated here. So we can remove. Median mark, we have that. Then I was supposed to teach you this work, but then that time power was on and off. I used another person's PC. We looked at, I was supposed to teach you presentation of data, but again, I talked about it using the phone. We said you can use a bar graph, you can use a frequency polygon, you can use a histogram, you can use a cumulative frequency curve. This is a bar graph. This is how it looks like. And I remember telling you a bar graph, you plot frequency against class intervals. You put your class interval on the x-axis. These are class, okay, class limits. Let's have class limits. It is also fine, class limits. Against the class limits like that. So we have something like this. Then we went ahead and also looked at the histogram. Histogram, we said you plot consists of vertical bars obtained by plotting frequency against class boundaries, and something like this. We said you can use a histogram to find a mode. And how do you do it? You simply plot frequencies against class boundaries. Then look for the highest bar. The highest bar, the highest bar is this one, so you simply draw diagonal lines from this one to the other one, then from this one to the other one. Then where they intersect, just come and read the value on the horizontal axis. That will be the mode. That's what we looked at when we're dealing with statistics. These have to be class boundaries. This has to be frequency. You notice the difference. This has to be class limits. This has to be frequency. So this one is a bar graph. This one is a histogram. The most common, of course, in exam is a histogram. This bar graph is not very common. And there's a question here. When I send you the work, you'll be in position to attempt it. Since we looked at how this is done, it was meant to be an example, but I did it using the phone. The other time when power was off, I used the phone to do this. I think I was doing something, then something went off, but I think you had understood it. The other one is a frequency polygon. This one, I think I had not talked about it, but this one, we plot frequency against class marks. You know how to get class marks. So you have frequency on the vertical axis, you have class marks on the horizontal axis. So you plot frequencies against class marks, and what you end up with is what you call a frequency polygon. Then it's not very, very common. What is common here is the cumulative frequency curve. Cumulative frequency curve, we said you plot cumulative frequencies against class boundaries. So the vertical axis will have cumulative frequencies, the horizontal axis will have class boundaries. And then there's an example here that we're supposed to do, but we didn't do because I was using another gadget where this work wasn't. So that's what we looked at. Then we also went ahead and looked at how do you find median, quartiles. I think at your level percentiles are not there. according to your syllabus. This is in Form 5. Median and quartiles using a frequency, cumulative frequency curve. So this is what we looked at, how you find that. And I remember I demonstrated this very well for you when I was using, I think it was some other person's laptop. The work is not here. This is what we did, and we're supposed to have an example here. This is what we're supposed to look at. Then I gave, suppose to have general examples, which unfortunately we didn't do like that. So at this moment, I want us to, since I've taken you through what we had looked at in statistics, I want to ask if there is something you've seen that I've just been talking about and you're not comfortable with, you can feel free, ask, and we give it time. We don't want to move forward when you have issues behind. So if of the things I've talked about here, there's a problem, or you're not still comfortable with statistics, we can dedicate this lesson. We do polish up statistics. Then in our next lesson, that's when we introduce sets. But if you're all fine with it, I think we shall continue to sets. Can I have responses on that? Are we comfortable with statistics? Or there are issues that you want me to polish up before you proceed? Yes? Yes, Makafu? You unmute yourselves and continue. You're okay with everything. Anybody with an issue? Jerome Katsime, are you fine with all the statistics?
Yes, teacher.
Okay. So that means that we don't have issues with statistics. All you need to do is to practice. Now I will need to get your responses. I'm going to send you this work. Then you attempt it and send me, so you can send me a feedback. Send your feedback to me and I see. Now these numbers, I'm going to send these now, which are meant to be general examples. I'm going to send them to you. This one is just a table. They're saying the table shows the mass of the newly born babies in the hospital. They have venue, mass. They're given the value of X, which is the mid-mark, value of F, which is the frequency. It's just like a puzzle that you're supposed to fill the gaps. Then you answer the questions following. Then number 2, this is a no-give. Of course, I said this axis, we didn't do it very well. This axis is supposed to be at 35.5, 34.5. This vertical line is wrongly drawn. It's supposed to be shifted to this point here. So you will draw it and shift it to that point there. Then there's this other one, this exercise, I'm going to combine all and give you the work on it. So let me switch off to statistics, to sets. That marks the end of statistics. Like I said, these statistics, you're going to find it still in Form 5, the way it is, and even a bit more detailed, but they'll still build on this. So if you understand it well here, then it won't be a problem then. Okay, so today we want to look at a set, sets. We want to look at sets. You've looked at sets before in primary. You've also looked at sets in Form 2, where we looked at basically 2 sets. So in this lesson, we're going to basically review 2 sets and make better sense of 2 sets. Then we shall proceed to 3 sets next time, because for you to understand 3 sets very well, you must have thoroughly understood 2 sets. So we're going to give 2 sets time. We understand the set language very well, then we can apply the same knowledge onto 3 sets. You can't understand 3 sets well if you did not understand 2 sets properly. So who can tell us the definition of a set? What is a set? What is a set? Somebody will unmute yourself and you tell us what a set is. Daniel Benjamin, tell us what the set is. What is a set?
A set is a group of data or some elements. A set is a group of elements.
a group of elements. So we're saying a group of elements of the same kind that belong together and can be used together. So a set, this thing versus is a group of elements. I don't know what this is. A group of elements or things of the same kind that can be used together. Yeah, it can be used together. So yeah, that's what we call. So this thing is. That's what we refer to as a set, a group of elements. You can say a group of students, a group of, a group of books, or a set of books, a set of students, a set of, so things that can be used together. So the symbols we use, there are many symbols that we use in statistics, in sets, but we're going to choose some few of them. Just going to talk about a few of them just for the sake of recalling. The first one is curly brackets. This type of brackets is called curly brackets. This one is the one we use in sets, and when you see something like this, maybe you see, and there is a word, let's say vowels, something like that. This one means we have a set, the set of vowels. So if you have A equals to that, that means so this is a set of vowels. I have a class, I'll handle it later. The set of vowels. So whenever you see something like this, these are the brackets we use, and you know that already, I know. Then the other one is member or elements of a set. What symbol do we use to say that something is an element of a set? Let's say we're given set A equals to A, B, RA. I don't remember those things. This is the vowels we have, maybe R, A, E, O, like that. These are vowels, something like that. Now, we can say A is a member of set A. This is how we write it. We use this symbol. That's the symbol we use to show that A is an element. A is an element of set A. We can also say maybe E is an element of set A, like that. That's how what to write. But R is not here. So if R is not a member of this set, then we shall say R is not a member. This is how we write. We write it, then cross. We use the same symbol, but then cross it. It is not a member of A. Z is not a member of set A, is not a member. So that's how we use those symbols. And some questions they will just ask you when they have used those symbols. So if you don't understand them, then you end up failing the question. So that's the symbol we use for a member of. This symbol simply says member of something. So then the other one is number of members. Number of members, we always use N, some N like that, stands for number of members. For instance, if A has elements these elements. I'll use the same example throughout. What are the number of elements in set A? Number of elements will be 1, 2, 3, 4, 5. That one you know. This one you know, so I may not take a lot of time on that. Then the other one is an empty set. An empty set, we either use this or that. You can say if they give you maybe let's say you have set A being the same as number of girls in SMARC. In SMARC, number of girls in SMARC. Here, I mean, yeah, not even number, girls in SMARC. So we're saying set A is a set of girls in SMARC, but SMARC is a boys' school. We don't have any girls in SMARC. So therefore, our A is an empty set. A has to be an empty set. Why? Because we don't have girls in SMARC. Or we can say A is an empty set by writing it like this. It is an empty set. Writing a simple set, but we don't put anything in them. A is an empty set. A is an empty set. So that's how we write an empty set. And the number of elements in A, will be 0 because we don't have female students in SMARC. So that is the other thing. Then the other one is intersection of sets. This one you know already. Intersection, the symbol we use is this one. That one shows common elements in given sets. If you have A equals to maybe, I'm using 1, 2, 3, maybe A, B, like that. Then set B equals to, let's say, A, B, C, D, E. Then they ask you to state the number of elements in both sets. Using set notation, we shall have A intersection B. That's how we write it. And this set will have the common elements. What are the common elements? We have A, B. So A and B. Those are the common elements in the two sets. Then union of events, union of sets. Remember, I'm using union of events because later on when you go to senior 5, and look at probability, there's something called union of events. So when I use it, just now I'm trying to bring out the two. So union of sets. Union of sets, this one represents all the elements in the sets given. All the elements in the sets given without, of course, repeating. So therefore here, if they say, using the same example above, A union B, we state all the elements in the two sets without repeating. So I have 1, 2, 3, A, B, C, D, E. That is the union of set A and set B above. I have all the elements represented, but I'm not repeating them. So I just have 1, 2, 3, A, B. There is A, B here, I don't repeat it. So I go to C, D, E, like that. So the number of elements in A union B will be equivalent to 1, 2, 3, 4, 5, 6, 7, 8. That's what we use. These are things we looked at in Form 2. So we're not doing anything different here. Subset, we use this symbol. I look for the proper symbol in my symbol. I didn't find it. So something like that. Elongated C, a C which is a bit long like that. C. A bit long like that. So if I have set A equals to, let's say we have set A has A, B, C, D, E. And my set B is equals to, let's say, A, B, like that. You see that all elements in B are in A. Here we have A, B, here are the elements of set B. Then A has A, B, C, D. So all elements in B are also in A. So here we say B is a subset. B is a subset of A, and that's the symbol we use. B is a subset of A, meaning all elements in B are also in A, something like that. So B is a subset of A. But in this case, A is not a subset of B. A is not a subset of B, so we shall say A is not a subset of B. This is what we use. A is not a subset of B. B is a subset of A. Somebody raised his hand. Can you please communicate? Somebody has a hand up.
So you answered my question.
Okay, all right. Okay. So A is not a subset of B. In words, A is not a subset of B, like that. Right? Here, B is a subset of A. That's what we have. Then what about a universal set? A universal set, so they can give you something like this. They can say, given set this, universal set, we use a symbol, this to represent universal set. This is our universal set, and they're saying this universal set is, let's say, a set of even numbers. Can they be even numbers? Okay. I'm thinking of, let's say, the numbers are all numbers between 1 and 12, like that. This is my set. This is my universal set. It is containing all numbers between 1 and 12. Then they say set, we have set A equals to, maybe we say set A has even numbers. And set B is the odd numbers, like that. Okay, I'm using wrong. So we have this, our universal set. It has numbers between 1 and 10. Remember, when they say between, it means that these are not inclusive. We're starting from 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, 11, 12. So we are talking about numbers. In fact, here we would have defined it as integers. I think that becomes a better word to use. We say integers. That becomes a better word. Integers between 1 and 12, like that. So that we have set A equals this and set B equals that. So what are the elements of the universal set? The elements of our universal set, we're going to look for the integers between 1 and 12. We shall have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then set A takes on even numbers from this. Of course, we can't have our universal set having numbers between 1 and 12. Then you have A, which is extracted from the universal set, having numbers beyond 12. Of course, A has to be extracted from this. Yes, Mayanja, your hand is up.
So you have included 12.
Yeah, I've included 12. It's not supposed to be there. Thank you for that observation. We said, because they said between 1 and 12. So 12 is not supposed to be among. So you have something like that. Now, even numbers from this, what would be the even numbers? Set A would be having elements 2, 4, 6, 8, 10. That is our set A. Then our set B would be having, we extract elements from this to be having 3, 5, 7, 9, and 11. So that means that our universal set contains all the elements, all of them. Now, like if they say members, or they say the universal set has people who visit a hotel, something like that. It can be people who visit a hotel or students in SMART, or it can be, it closes up everything. The universal set contains all elements, is the one that covers all the elements. That's what we call the universal set. Then lastly, the last term that we're looking at is complement of a set. If they say, now like here we have the universal set, our universal set is having, oh, sorry, I will use the different symbol. Our universal set, which is this, is having elements 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. That's our universal set. And this is the universal set like that. Then our set A is having elements 2, 4, 6, 8, and 10. They can ask you to find what are the elements in set A prime. What are the elements in set A prime? These are elements that are not in set A, but they are in the universal set. Elements which are not in set A, but they are in our universal set. So what are these elements? You just get elements. We have set A will have elements which are not here. Those that are not in this A, which are outside set A, so that will be 3. It is, yes, it is in the universal set, but it's not here. We shall have 3, we shall have 5, we shall have 7, we shall have 9, we shall have 11. Those are the elements that are in the universal set, but they're not in set A. That's how we write it. So they can also ask you to find the number of elements in A. Number of elements in A will be 1, 2, 3, 4, 5. You write that. Then number of elements in A prime will be the same as 1, 2, 3, 4, also 5, like that. So it's just by coincidence that they're the same. They're not always the same. Not always the same. Sometimes they're not the same. So that's what we have with the two sets. That's what I wanted to remind you about those terms, because we're going to use them very often. So you need to know them. So like I said at first, can I have a few questions? If you have some questions on this, or if there is a term you think I've left out and you found it somewhere. Yes, please.
Teacher, is prime the same as complement?
Yeah, it's the same as complement. Prime is the same as complement. You can use them interchangeably.
Teacher.
Yes, please. Any other question? From what I've talked about from the beginning, if you have an issue, please feel free to bring it forth. We've talked about the curly brackets. Those are the ones we use for sets. We've talked about member of a set. Which symbol do we use? We use that one. We use that symbol. You've seen it there. Number of members, we use that one. We use small n to stand for number. Then an empty set, I've shown you what we use for an empty set. Intersection of sets, I've told you that. Union of sets, I've given you. Subset, I've given you. Universal set, I've talked about it. Then complement or the prime, I've talked about it. So if you don't have any question on that, then let me introduce, we're going to talk about two sets just to make sure we remember everything before we proceed to three sets. In fact, our major concept here is three sets, but of course we can't go forward unless we know what is before us. So, two sets. Of course, here we'll be doing just basically two sets. Somebody likes meat, another one likes beef, this one likes rice, this one likes posher, this one likes, we'll always be dealing with two sets. But do we understand the terms or the regions of two sets? So I'm going to draw here a set. I label the regions. Then I'm going to draw two sets here. I mean, here we have a set, we have that. I label the regions, then you help me name those regions using set notations and statements. We are going to use both statements and set notations to, this is, let's say, this one's not looking good. Let me move it. So we have those two sets. These are the sets we have. I will not balance them well, but okay, let me just use this. Let's say you have two sets, set A and set B, whose Venn diagram looks like this. Those two sets, something like that. We have, let's say this is set A, this is set A, and this is set B. We are going to label, and then this is our universal set, like that. Let's say I have region 1 here, I have region 2 here, this is region 2, this is region 3, this is region 4. So in words, I'm going to give you an example, then you help me complete the rest. If I have, let's say they're talking about region corresponding to A, but not B. Region A, but not B. Here, in using set notation, we write A intersection B complement. That's what we use as the set notation. A, but not B. So which region corresponds to this? Can you tell me the region that corresponds to A, but not B? Or A intersection B complement? Is it region 3? Is it region 4? Is it region 1? Is it region, what region is that?
Region 1.
That's region 1. Region 1. Then the next one is region A complement. A complement, sometimes you write in words to be not A. They'll say not A. Which region?
3 and 4.
That is region 3 and 4. That is region A complement. That means we're dealing with A outside A, which is 3 and 4. Then the other one is region, of course, B complement. B complement, that's not B. Not B. Will be the same as, which regions are those?
1 and 4.
1 and 4. Then the other region is neither A nor B. How do you write that using math notations? Like I've been writing here, A intersection B complement. How do you write that? Neither A nor B. We write it as
A union B.
Into brackets complement.
A union B into brackets complement.
Complement.
Which region is that?
4.
Region 4. Yeah, neither A nor B. So that means that we're outside the two sets. We're outside the two sets. That's region 4. Then the other one is, the other one will be A and B, of course. A and B, that one we know. A and B, and B, that will be the same as A intersection B. And which region is that? Of course, it is region 2. Then lastly is, let me see which region have I left out. The region I've just talked about, I've forgotten. Region, they can say, That one has disappeared. Okay. When I recall, I'll bring it here. I've forgotten it. Okay. B but not A, we know that. B but not A. That one we know it to be the same as A complement intersection B. That we know, and that's region 3. There's one that I've forgotten. The other one is this one. A or B. What does A or B mean?
A union B.
A union B, perfect. A or B means A union B. And this will be the same as region 1, 2, and 3. So these are the terms that we need to be conversant with. Let's pay attention. These are the regions that you're supposed to be conversant with when you're dealing with two sets. They will, of course, use words. They can give you, like I've given you here, they can just use words, neither A nor B. They can see B, but not A. A and means intersection, or means union. That's the other thing that you should know. And is for intersection, and or is for union. You'll even find this when you go to A level and you're doing statistics and probabilities. The topic sets, we don't have sets in A level, but we have probabilities. And under probabilities, we look at these same terms here: union, intersection, or, and those things there. So having had a recap of what sets are, let's go ahead and look at how we can apply that in these examples. We have some few examples here, but the work is trying to intermingle itself. Okay, let me see what I can do. I can remove this by cutting it. I come and paste it here. Okay, so we have a question here. This is our example 1. It says in the Venn diagram, E, which is our universal set, we're now using symbols, and I think we were conversant with them. E, which is our universal set, is standing for the people in a hotel. Maybe somebody went to, can you try to, you mute yourself, please? Mute yourself because we are having an echo this side. So the universal set is for the people in a hotel. Maybe somebody went and was making a research or survey something in a hotel and got some data, got some data. So the universal set is standing for the people in a hotel. Then B, set B is standing for people who like beef, and E is standing for people who like eggs. So we have, this is our universal set, something here, but the words have intermingled with it. We have this our universal set, like that. So we have, this is a set of people like eggs, this is a set of people like beef. Now the question is, how many people like beef? Let's answer this. This is a simple quiz. You do it very fast and you proceed. How many people like beef? Can somebody tell me the answer? How many people like beef? We know those regions already. This is the region for beef, the circle. This is the circle for the beef. So how many people like beef? You just count those crosses and tell me how many people like beef.
Eight.
8 people. So the number of people like beef, number of beef is 8. You simply count those crosses. Then how many people like eggs? That we can write as number of E, number of those who like eggs. How many are they?
3.
Those who like eggs are 3?
7.
There are 7, yes. You look at the old circle. This is for the eggs. This circle is for the eggs. Oh, sorry.
But
They didn't say eggs only, no?
the question is saying eggs, but not
Eggs but not
saying
beef. Yeah.
egg.
Eggs but not beef. That's perfect. Eggs but not beef. I think I was writing this. Let me delete this first.
3.
It's 3. It's 3. That's the correct answer. Those who like eggs, and this is a wrong notation. It's not supposed to be like this. The rubber is also not coming. Eraser. The rest is not coming, so let's ignore it. Let me just write it here afresh. Number of those who like eggs, but not beef. So this is how we're supposed to write it, but not beef. That's how we write it, and the answer is 3. Okay. How many people like beef and eggs? Number of beef intersection. We said and stands for intersection, and eggs. This gives us how many? 4. 4. How many people are in the hotel? How many people are in the hotel? So there we're looking for the universal because they say the universal set is standing for in the hotel. Number of people in the hotel is 18.
18.
Okay, we're going to count together and we see, are they 18? This is 4, this is 4, this is 11. Yeah, 18 when you add the 7. That is it. Then how many people like neither beef nor eggs?
7.
Number of neither beef. So we're writing this, comma.
7.
There are how many?
7.
There are 7. Like
7.
there are 7 people who like neither beef nor eggs. So that's what we have. That's how our Venn diagram, that's how we extract information from the Venn diagram. The most important thing you should know is how to write simple represent statements in set notation form. How do you change a statement in set notation form? If you do that well, then you'll get it well. So if they say how many people did not like eggs and beef? How many people did not like eggs and beef?
7.
7. It is the same as saying how many people like neither. This is there is a D missing here. How many people like neither beef nor eggs? So this statement here can also be written as, this statement is the same as also saying how many people is that people did not like eggs and beef. So the two questions, these two questions are the same. How many people did not like eggs and what the other one I've been typing? Did not like eggs and, it's not typing, okay. Did not like eggs and beef. So that's what we do for number 1. Let's do the number 2 here and also see. This work has also intermingled. Let me copy it. I cut this, control cut. I come and put it here. Control V. Also cut this, control cut, put it here. Yeah. So this is our Venn diagram. They are saying the universal set represents number of boys in Form 3 class. Then C is standing for member of cricket team, and R is standing for member of rugby team. Now the first question is, how many are in the rugby team? How many are in the rugby team? So the question, if you write this in set notation form, they're asking for how many are in the rugby team, number of R. How many are there in the rugby team? How many?
9.
There are 9 because the circle of rugby is this one. So we consider everything inside this circle of rugby. So that would be 5, 4 plus 5, which gives us 9. Then the other one is how many are in both teams, number of rugby intersection cricket. This will be, how many are those?
5.
5. How many are in the rugby team but not the cricket team? How many are in the rugby team but
4.
not? So we put
4.
4. So this is the same as writing how many are in the rugby team only. This also is as good as saying how many are in the rugby team only. Let me put the cursor here. It is not. How many are in the rugby team only? Let me put that question also here. How many are in the rugby team only? Yeah. So that is it. How many are in the rugby team only? That's the other question. That's the other way they would have asked for that. Then how many are in neither teams? How
20.
How many are in the neither teams? So that means that you're looking
20.
20. So that is 20. I'll go to draw, and I will draw, right? Number of rugby union cricket complement. We say this is also the same as writing number of rugby complement intersection cricket complement. From the previous example, I think you noticed that. So you can also say how many did not like rugby, or how many are not in the rugby team and cricket team. How many are not in the rugby team and cricket? So they are not in any, they are not in both of them. How many are not in the rugby team and the cricket team? So something like that. So how many are there in Form 3? How many students are in Form 3?
31.
31. You look at your universal
31.
set. Number of the universal set, we have 31. There are 31 members. So that's how we answer that number 2. Let's go to number 3. Since we're just reviewing, we're just laying a foundation for 3 sets. We should not spend a lot of time on this. We're just laying a foundation for 3 sets. So number 2 says it is given that the universal set has this, set A has this, and set B has that. List the members of set A complement. What are the members of set A complement? Yeah, using your notebook, you go through it. Just look at it very fast and tell us the members of set A. We have the universal set, we have set B. And we defined our universal set, set A complement as members which are in the universal set, but they are not in set A. So our universal set is this one. Set A is this one. Which members are here in the universal set, but they're not in set A? If that is a bit hard for you to visualize.
1.
1, yes.
4.
6.
A complement equals to, you say
1, 4.
1.
1, 4, 6.
1, 4,
4 and 6.
6. Yeah, it's saying those are the elements of set A complement. But you can also draw a Venn diagram to help you visualize, help you see what you're trying to do. If I put a Venn diagram here, let me not use a lot of space.
Sorry, in your class.
Sorry? What are you saying?
Sorry.
Then we have another set. So this is our set B. Okay, so we have our set A. This is, let's say our set A is this, and our set B is that. This is the universal set. Now, what are the elements in set A? We have 3, 4, 5. I mean, set A has 2, 3, 5. This one has 3, 4, 5. What are the common elements in A and B? What's the common element? We have 3 here, we have 3 here. We have 5 here, we have 5 here. So this is 3, 5. This is there. Then what is in A only? A only we have 2. Then what is in B only? We have 4. Now, which elements are in the universal set, but they're not in these ones? We have 1, they have not been repeated anywhere. 2 is here, 3 is here, 4 is here, 5 is here. We have 6. Those are the 2 elements outside. We don't even put a comma, we just put 1, and maybe you have 1 there, we have 6 there. So, list the members of A complement. I'm looking for members of A complement. So, what are the elements in the universal set that are not? This is my A. This is my A. What is A complement? Everything outside this, and you gave me 1, 4, 6, which is very correct. That's A complement. Next one is, they are saying B complement or B prime. What are the elements of this set?
2, 1, 6.
2, 1, 6. 2, 1, 6. 2, 1, 6. If this is my B, what is outside B? 2, 1, 6. Yes, that's perfect. 2, 1, and 6. You may write them in that order. The order doesn't matter as long as the element has been stated. The other one is Roman number 3. We are looking for elements of A complement intersection B. That means that we're looking for elements of set B only. What are those elements?
4.
It's only 4. So it has only 1 element. That is in set A complement intersection B. Roman number next, that's Roman number 4. We are looking for elements of A union B complement. Who can tell me the elements of that set?
1 and 6.
1 and elements of
1 and 6.
1 and 6, A union B. Now, in this case, if you want to know elements of A union B, remember
2.
What are the elements of set A? Elements of set A. A has 2, 3, 5. Those are elements of set A. What are the elements of B complement? The elements of B complement are, we've just formed them as 2, 1, 6. Now, if they ask you to state the elements of A union B, you state elements in both sets, in the 2 sets, but avoid repetition. That's the definition of union of events. Have all elements together, but ignore those that are being repeated. Just don't repeat. Now here we have 2, we have 3, we have 5. Yes. This will be 2. We have 3, we have 5. Then which element is here that's not here? There is 1, there is 6. So those are the elements of A union B complement. Then Roman number 5, what do we have? They are saying A intersection B complement. A intersection B complement. What are the elements of this set?
1 and 6.
Somebody says
2, 4, 1 and 6.
3,
2, 4,
4,
1,
1, 6.
1, 6. Do we understand why it is like this? So I simply look at my set A intersection B. A intersection B has 3, 5. That's my set A intersection B. Now, if they want me to state A intersection B complement, I look at elements in the universal set that are not in my set A intersection B. That's what I do. Which elements are in the universal set that are not in the set A intersection B? I go to my universal set, it has 1, 2, 3, 4, 5, 6, but my A intersection B has only 3 and 5. Has only 3 and 5. So all these other ones will make my set A intersection B complement. Hope you're getting this, because these terms are the ones we're going to use very often when you find the higher order questions, the ones that you bring in your name. They are the ones that have these terms. They'll be using these terms to put you off. But if you know them, then it will be very easy for you to pass them. Yeah, so can you now answer the last one? They want you to find A complement intersection B complement. How do you find that? A complement intersection B complement. What does it give you?
1 and 6.
1 and 6. So here, what do? I look at my set A complement. What is it having? A complement has 2, 1. B complement has 2, 1, 6. What is my A complement? It has, did I write A complement somewhere? It has 1, 4, 6. So A complement, intersection B complement, we are looking for the common elements. What are the common elements in the two sets? What is in A complement and is also in B complement? In this case, we see it is 1, 6, 1, 6. So we have 1 and 6. That's what we do. Now, I want you to do, I'm going to give you some, like 3 minutes. 3 minutes, you do for me this number here. This second number. Draw a Venn diagram to show the following. This, that. I want you to do it. And then you help me answer the questions that follow. So you do it. I'm giving you 2 minutes. Two minutes, you do it, then we continue. What have you found as the answers? For number 2. Yes. 36. Somebody has 36. Somebody has the number of elements in the universal set as being 36. Can you share with us how you did it? You can turn on your video and you show us what you've done. Somebody who has given me the 36, turn your video on and you show us your Venn diagram, how it looks like. Yes, Mayanja, you can show us, bring your work to the camera and we see what you've done. Yes, bring it closer. We can't see it, we can't bring it clear. It's almost being clear. Bring it. You can see something. Are you seeing his work? Are you seeing the work that he's sharing with us? He has a Venn diagram. There is P here, there is Q here, there is, I think this is 10. This is, what is this in set? What is in this set here? I'm not seeing it well. Mayanja. Okay, thank you for the work. Let's work it out together here. We can see something. You can see something clear there. So let me draw. Let me show you here how this would look like. We have our Venn diagram. We have two sets in it. Let's say we have set that, then we have another set which looks like this, inside it, like that. Okay. Like this. So what have they given us? They have given us the number of elements in set P complement. Number of elements in set P complement are 6. Number of elements that are not in P and Q, you know, this is like P union Q complement. I remember we looked at how this represents. So we shall have, let me write here, we have our universal, of course, is this. We don't know how many elements I need. They have not given us. They have not given us. They have not given us the elements in the universal set. Then Q complement. If this is my Q and this is my P, we have that. Q complement means everywhere outside Q. We don't know anything about that, but we know what is inside both. P intersection Q is 18, so we know this is 18. It has been given. Then outside both of them, P complement intersection Q complement is 2. So the 2 is outside. We know why you put this one outside. This is like saying they didn't like both this and that. They didn't like both of them, something like this. Or it's the same as saying P union Q complement. We just did that in the previous examples. It is 2. So we have that. Now we don't know what is in Q only. We don't know what is in we don't know what is in Q only. We don't know what is in P only. So we can let this one be X and let this one be Y, like that. But then in our question they are saying number of P complement, number of elements in P complement, there are 6. There are 6. That means, where is my P complement? My P complement is power is off. That's a big challenge with this online thing. So when power goes off, you can have a lesson. Okay, sorry, my battery, I mean my sorry, my battery went off. I'm still connecting. Power is off this side, so I'm going to be very fast and we conclude the lesson because my power is off. The battery this way, electricity has gone. So I need to be very fast and we conclude this before it leaves us in suspense again. So we're saying here, number of P complement is 6.
Even here.
Hello? My power has been off, so let's wind up this very fast because the electricity has gone this side. I'm just using the battery of the PC, which is a bit weak. So anytime from now, to be blacking out. So we need to be very fast and we wind up what we're supposed to do. So we're saying number of P complement. P complement is outside P. This is outside P. All this is outside P, like that. So we shall have the X and the 2 being outside P, and that will be the same as, of course, we said this is the same as X plus 2. So from this we can see that our X is the same as 6 minus 2, and X becomes 4. That means that those who liked Q only are 4. This one has only 4. Q only, they were 4, because we found the value of X. How did we find it? We used P only. Because P only, I mean P complement represents those that are outside P. So when I shade outside P, you'll have X and 2 inclusive, and that gives us 4. Then the other one is Q only. They give us number of Q only, and they said this is Q only is 10. Q only is 10, but when I shade Q only, I mean Q complement, not Q only. Q complement is outside Q. So when I shade outside the Q, I'll shade, of course, this side. Outside the Q, all this, even the 2 will be inclusive. You see that all this is outside the Q. All this is outside the Q. All this is outside the Q. Outside the circle of Q. So we shall have Y plus 2. Also inclusive Y plus 2. So you end up with Y equals to 10 minus 2, which gives us 8. And therefore here we can say number of those that liked P only, that is P intersection Q complement, they were 8. So we have P only, we have this is 8. Now the question wants you to find those that are in the universal set. You just add everything inside. That would be 4 plus 18 plus 8 plus 2. What do we get? This gives us, what do you get? Can somebody tell us the answer? What do you get when you add 2 plus 8 plus 4 plus 18? It gives us what? Ochailab? Ochailab? Can you unmute yourself and tell us the answer? That's why I told you to sit with your calculators near you so that will keep giving us these answers. Ochailab, are you in class?
28.
You get?
To that we get. Sorry.
You get?
So
What do you get? Just adding, simple arithmetic. This is not something complicated. Just adding.
32.
You get 32. So the number of
get
elements
32.
in the universal set, there are 32 elements. A friend of ours gave us 36, but I think there was some miscalculation somewhere. Miscalculated somewhere. It is supposed to be 32. And that's what you're supposed to do with that number. You know? This is a possible, in fact, this is a possible number. If you've checked in the newspapers, then the questions are always put in New Vision. You'll always find such questions there. You know? You always find these questions there. So there are many other questions, like this one here, they're saying given the universal set equals to this. Okay, before I proceed, do you have any questions about this before we continue? Any questions on this before we continue? Mugabe, Elijah, are you okay with what we just done here?
Yes, sir, it's fine.
Okay. Now they're saying given the universal set, we have the universal set 1, 2, 3 up to that. They're saying this universal set takes on numbers from 1 up to 9. A subset of the universal set consisting of prime numbers. Yes, Obang, Jesse, your hand is up.
Why did you use unknown?
What do I use? What did I use? Unknown.
Yeah.
Because we don't know it. We don't know what the value of X is. We don't know what the number of people who liked only Q are. So that's why I'm using unknown. But you can also use the set notation itself. You can say this is the number of Q intersection P complement. You can use it in the notation itself. Here is the number of P intersection Q complement, like that. You can also use the set notation. So instead of adding X here, you can say the number, but you see how long it is. Okay? You can see how long it is and how time consuming it is. I can say that plus, then I make it a subject. Even here, I can say number of P intersection Q complement plus 2. Then I look for it. You can use the set notations themselves. Okay. Is that okay?
Okay,
Juan?
thank you.
It's okay.
Okay. So here they're saying, given a set, the set is. Hello, mute yourself. Mute yourself so that you don't have that noise inconveniencing us. So here they're saying, given that the universal set is this, A is a subset of the universal set consisting of prime numbers. Write down the members of A. Now, our universal set has these elements. Then they are saying A is a subset of the universal set and has prime numbers. Can you give me the elements of set A? What would be the elements of set A? They are saying A is being extracted from this, but A should have only prime numbers. It is almost the same as this, but has only prime numbers. So